Hello everyone, today I'm going to show you how to build a quadcopter of S500. So these are the parts I've got. The first is I've got the skid of S500 Quadcopter. So in this kit I've got a set of props, 12 props of 1045. These are the props that I have, so keep those here. Also, these are the frames, wings, which these are 4 frame wings. This is the manual for the build. It's S500 carbon fiber frame. The landing gear is carbon fiber, and the hands have a reinforcement carbon inside, which will support the frame. It's a pretty light frame compared to 450. These are the landing gears for the quadcopter. This is an anti-vibration mount for APM. I've chosen APM as the flight controller. A bit of research that I've done, and I found that APM has a pretty good features when it comes to autonomous flight. It includes pretty good modes when it comes to GPS and GPS hold, and other modes are pretty good rather than NAS 32 and KK 2.5. So I like APM. A bit of heat shrink that I've asked for, and then I've got the motors. The motors that I've chosen is EMAX 2213935 kV. So these are pretty good motors. When it comes to choosing a motor, I think you need to go for the best motors, or at least one of those trusted motors. So DJI also have their motors, but I think from AliExpress, from where I've got this product, there are a lot of fakes DJI motors, so I prefer to go for EMAX. It's pretty good. These are the shafts can be anti-clockwise. This is a anti-clockwise motor with a black shaft. You can see, you can add the props here, and you can close it like that, and it will self-tightening kind of a motor. Same, I've got two motors of the same type, anti-clockwise to EMAX 935 kV 2213, and I also have the clockwise motors. These are the clockwise motors that comes with a red cap on top, and I have got one power module. This is APM power module. This is pretty important when it comes to power module, because the power module provides clean power from your LiPo battery to your APM power circuit. It's got a Dean's connector or T connector at the end, because the battery I have that is also having a T connector. That's why I've chosen a T connector for my power module to APM. Now this is the LiPo I have. I've got a 550-200 mAh 11.1 volt battery, which has got a 30C, which is pretty kind of, it's a heavy one. I think it will give me probably 15 to 20 minutes of flight time, because if you look into the calculations, right, what you need to do is you need to calculate your kind of voltage you require for your quad, because I've got ESCs which are 30 amp, 4 ESCs, so I'll show you that, and it will be around about 30 to 120 amps overall. And so if you multiply 5200 by 30, it will be around about 2700 kind of a voltage, which would be pretty good enough for my quadcopter. Alright, so this is the T connector which I will connect it through my power module, and then I will use it as a endpoint for my power board in the quad, and this end will go into our APM. Okay, so back to these are the landing gears for my quad, which fits to this landing gear module here, and it connects to your quad. Also, this is my GPS for my quad and GPS stand, and these are the some battery holder and battery stand for my quad. So that's overall. I've got some pieces here. So I'll show you now the set of screws and the adhesive tapes. These are the motor screws and all. So that's overall the kit. And now coming to the different aspects of Ardu Pilot. This is my flight controller. This is Ardu Pilot 2.6, and this is the GPS module with built-in compass. I've chosen EMAX M8. M8N is the one which has got pretty good range. It can also connect within home, and this is my receiver. This is Flysky FS-i6P IA6P. So this is the receiver that I've got with my transmitter. So I'll show the transmitter later. This is my flight controller, and this is my GPS, and this GPS cable is having two connection points. One is mentioned the GPS, which connects to the GPS port, and another one is my compass, which connects to I2C port. You can see that, right? So it's got two wires. One is the signal, another one is the power, and GPS got 5 port, which one is empty, one is power. Sorry, one is ground, power, signals, right? Two signals and one ground, and red one is your power. So this is the ports you have. This is your power module. So whenever what I need to do is I need to use this power module, and I need to connect this in the power module port like this, and then one end will connect to the battery and another end will connect to my power distribution board in the flight controller, right? So this is what I've done is I've arranged these three in a flat board, so that when I do my initial setup and initial calibration, so it becomes easier to do it, because when you connect this with your computer and use your ground station to configure the APM receiver GPS, you need to do a lot of turn here and there. So it's pretty difficult to do it when it's already mounted. So that's why I have kept these three separate, mounted it temporarily on a piece board, and then once the configuration will be done, and then I will connect it to my quadcopter. So now going back to the transmitter. So I've chosen Flysky. This is a new transmitter that's come. So it's Flysky FS-i6S. It's got a touch screen and it's pretty neat. So this is the one I've got, and I'll show you. So here's the transmitter, right? So I take this up. This is how it looks. It's pretty neat. It looks pretty good, and it's basically supports 10 channels. But the receiver I have, which is given with this, it's a 6-channel receiver. This is a 6-channel receiver, but this transmitter can support 10-channel receiver as well. So though I do not need 10 channels as of now, but it's okay. So it's pretty good. It has got touch screen, and it has got a pretty soft grip. The aggro looks are pretty neat. It runs with 4 AA 1.5 volt batteries. It doesn't have a LiPo as a power supply, but it's okay. I can live with that. Other than that, it's got a self-centered throttle stick. It's a mode 2. You can change it to mode 1 based on your preference, but I'm good with mode 2. So it's self-centered, and it's got two position switch. One that is switch A, and it's a 3-position switch. As switch B, it's switch E is also 3-position switch, and this is also a 2-position switch. And this got a dialer kind of a thing, which is a metallic dial-up button, which you can use for your gimbals and others if you have. And it also has 2 buttons here, which I think can be used for landing gears or takeoff module, or your LED lights or something. You can configure those. Other than that, it's basically also have one USB port, which is used to connect this receiver with your laptop or computer to get the firmware upgrades, or also for your virtual simulator kind of a thing. It's also got a PS2 port for connection as well. So you can see there's 2 power buttons. If I press one of these, nothing will happen. You need to press both of it, and it will power on. Right now, the best part is it's got touchscreen. So if I you can see the different channels. This is channel 1, this is channel 2. It's got 10 channels, but my receiver is a 6-channel one, so I will not be able to take 10 channels output out of my receiver. You can see pretty neat. If you don't like this self-centered throttle, there's a YouTube video which you can look into how to remove this self-center thing and make this a normal one. So it's up to you, but it's pretty good. These are the touchscreen telemetry values which can reflect once it's power on. So right now I do not have anything. So it's a setup. You can see, you can put your endpoints configuration. You can do the reverse. You can do auxiliary channel setup. So this channel is used for flight mode, so aux5 and all. So I'll show you fail-safe RC bind. So binding is pretty simple in that, just you need to click on the bind button. Before that, you need to make sure your receiver is connected in the bind plug in the B and VCC port. This is the port where you need to connect your receiver, and then the bind channel, and you click on bind, and it will bind with your receiver. So it's pretty straightforward. You also need to provide a power source to your receiver. So this is what the receiver looks like. And going back to this, how I've connected my APM as of now, just for the configuration, is I'm using PPM for my signal. So PPM is basically just needs one set of wires of a servo. That is, this is a signal one, white one is a signal, red one is your power, black one is your ground. It straight away goes to PPM channel, that is the channel 1. So I've done signal on top, that is white, red and black, and it goes directly to the port. It also supports iBus and SEZ and servers. If you're using iBus, you can use those channels for the configuration. But I'm using PPM, that's why I'm using a single servo cable. And in the APM, what I've done is I connected it into input 1. Input 1 is where the PPM is connected in a Quadcopter 2.6, and then you need to also connect 2 and 3 on the signal channel, right? So what I've done is I've taken a 3-pin servo, short the first 2, so I've soldered it, and then this is a 2-channel kind of a connection that I've done. It's 2 and 3 on the top rail. This is I've shorted it and covered it with the heatsink, and this is one which is going to this power. So that is the overall configuration for initial setup to configure the RD pilot. I've got this RD pilot connected to PPM to my receiver, and GPS, and my compass is also hooked in, so that I can do the initial calibration. So that's the basic parts that I've got, and I will get into the detailed installation on another video. Just one more point before you hook up your Autopilot to your computer and configure it. Make sure there's a power module. If you are using power module like this one, your JP1 jumper, which sits right inside this, you need to take it out. I repeat, when you are using power module, make sure your JP1 jumper is taken out. So if you don't do it, what happens is, if you look into the wiki of Autopilot, once it's been powered on by power module, it can supply power to all your input channels. That is basically on the middle rail is linked. If one is being powered through this one of the channels, all the input will have the 5 volt power, right? And similarly, this board basically has 2 sections of circuitry. One circuit is like this, another part is like this only. So when you connect the jumper, it basically passes the power from this area to the output port, right? So if you have a JP1 installed here, right, if you install the JP1 small jumper, then if you power from a source to APM through power module, the output will also have a power which will be passing through the JP1. So that is not recommended at all, right? So if you want to have your outputs and your servos to be powered, use your ESC and ESC can help you with a 5 volt circuit to pass the power on that. So in short, you do not use JP1 if you are using power module, right? You can refer to the wiki for further details. And let me show you the ESCs that I've got. So what I've done is I have already soldered my ESCs in my power distribution board of my quadcopter. So this is S500 Quadcopter power distribution board. So what I've done is I've soldered a Dean's connector that is basically a T connector at the back. So if you see, this is positive, this is negative, similarly this is positive and this is negative. So I've taken this connector and soldered it in this like this, okay. And these are my Simonk 30 amp ESCs, right? So this has got EVAC kind of a it can supply 5 volts to my APM and to my other servos if I need to. So I do not have a servo, but still it's there. So it's pretty it's got a 30 amp, and this is your positive power module. Sorry, this is your positive wire and this is your negative wire. Red is positive, black is negative. What you need to do is you need to solder this positive on your positive side and negative on the negative side. So this has got 4 positive negative ports for your ESCs because it's a quad. If you buy a board for hex, you will get 6 positive negative part. So you need to connect your red on the positive side, black on your negative side. So that's what I've done, positive, negative, and these are the 4 ESCs which have been connected to my power distribution board, along with one Dean's connector which I've connected so that I can use this power module, right? And what I need to do is I need to simply connect it here, one end like this, and and then I need to connect it to my battery. So that way the battery will provide required 12 volts 12 volts to this circuit, and then ESCs can get the power from it, and it will also provide clean power to my APM through this port. Okay, so that's overall parts and the things that I've got for my S500. I will come back and show you the details later, how to configure the initial APM and how to tune your barometers and others. Thanks for watching and hope that's pretty helpful, and see you later then. Thanks.